Okay, so let's talk a little bit about game theory, and let's do it in the context of a specific example. The key to game theory is to understand that you need to break down the strategies, not to simply look where you think the best outcome is. Sometimes that's hard to do, and sometimes the best outcome isn't actually where we expect the game to end up. Sometimes it is, sometimes it isn't. But if you follow the logic, if you follow the sort of rules of game theory, then finding the Nash equilibrium is actually typically quite easy, and it usually makes a lot of sense once you figured it out. So if we look at this particular example, we have two companies, Coke and Pepsi, and they each have the same decision to make, which is, do they advertise or do they not advertise? Over here we have the assumptions of the game. It's simultaneous. There's perfect information. This means that both companies know the payoffs. So in a sense, because the firms know that each other are profit maximizers, the motives of the firms are known. We're going to assume it's non-cooperative. That is, that Coke and Pepsi don't work together to decide this as a group. We'll explore whether that would be possible given the potential payoffs in a minute. And just for a practical consideration, when we talk about these payoffs, the payoff in the left goes to the left player, or the first payoff goes to the left player, and the second payoff or the right payoff goes to the top player. So just sort of keep that in mind. So for example, if both companies choose to advertise, Pepsi would get $90, Coke would get $90. If Pepsi chooses to advertise while Coke chooses to not advertise, Pepsi would get $120 and Coke would get $60. Okay, and the easiest way to go about thinking about the game and strategies is to go ahead and think about the game in terms of potential payoffs. That is, that as you develop the strategies of the game, what you should do is focus on the outcomes of any given strategy relative to the opponent's strategy. You want to pay attention not only to your outcome, but you also want to pay attention to your opponent's outcome. This will oftentimes dictate to you what is your best response. And that's the other thing we want to think about this. We want to think about decisions here as best response. As we go through and we develop strategies and we uncover things about our opponent and our opponent's potential strategies, we will often want to frame this as, what is the best response? What is my best option given an assumption I may make about my opponent? And often in these situations, what you'll do is you'll ask yourself, well, if I put myself in the shoes of, for example, Pepsi, and Coke makes this decision, what would be Pepsi's best response? So this is the way you want to think about strategies. Okay, so the way that you should think about each potential outcome of the game is that it's represented by the payoff function, here pi. And here what we mean is that each player, Pepsi and Coke, has their own payoff function, and in both cases the function is decided by the choices of both Pepsi and Coke. So in other words, the outcome of the game needs to be strategic in the sense that since the outcome is determined by the choices of both players, this implies that the best response can only be found by considering what is the best response of your opponent. So let's go through the strategies. But first, let's see how the payoffs work. So, for example, if we're looking at Pepsi's payoff, and we consider the outcome where they both choose to advertise, that is in this particular quadrant, and we can see that Pepsi's profits would be $90, and we can also see that Coke's profits at that particular outcome is also $90. So this is the way we want to think about it. So in both cases, Coke and Pepsi think about this outcome of the game in the context of what are the respective profits that could be made at this particular outcome relative to any other potential outcome. In other words, Coke goes, well, let's assume that Pepsi does choose to advertise. Can I do better than choosing to advertise? In other words, would it be better, in fact, for me to not advertise? And so if we look at that outcome of the game, where Pepsi advertises and Coke chooses not to advertise, we see that in fact Coke does worse than if they were to advertise. So again, this is the way you want to think about it. You want to think about it in terms of payoffs, and you want to think about it in terms of not comparison between Coke and Pepsi, but compared to what is each of their potential outcomes. So in other words, we'll ask ourselves, we'll put ourselves in the shoes of Coke, and we'll say, if Pepsi chooses advertise or not advertise, what does Coke want to do? And of course, we'll use the payoffs to answer that particular question. So let's start with the question, what would Pepsi do if Coke chooses to advertise? Again, remember, information is perfect. Each competitor knows the potential payoffs of the other firm. So Pepsi asks themselves, if Coke chooses to advertise, what do I want to choose? We can see that if Coke advertises, that puts us in one of these two outcomes, quadrants, if you will. And we can see that Pepsi does better by advertising, as $90 is of course greater than $80. Again, just think about the rationale here. If Coke chooses to advertise, Pepsi advertises and makes $90, or doesn't advertise and makes $80. $90 is better than $80, therefore, when Coke chooses to advertise, Pepsi would choose to advertise. Now, what happens if Coke chooses to not advertise? Well, Pepsi can choose to advertise and make $120, or not advertise and make $70. Again, we can see that Pepsi's choice is to advertise. At this point, we can refer to advertise as Pepsi's dominant strategy, because regardless of what Coke chooses, Pepsi wishes to advertise. Okay, now let's ask ourselves, if we were Coke, what do we want to do if Pepsi chooses to advertise? Well, if Pepsi chooses to advertise, that puts us in one of these two quadrants. Coke chooses to advertise and makes 90, or not advertise and makes 60. Again, Coke wants to choose advertise. If Pepsi chooses to not advertise, Coke chooses to advertise and makes 100, or not advertise and makes 70. Again, we can see that Coke has a dominant strategy to advertise. Regardless of what Pepsi wants to do, Coke will choose to advertise. In this scenario where there are two dominant strategies, it's actually very easy to find the Nash equilibrium. Just employ the dominant strategies, and that will always be the Nash equilibrium. Note, this only works if there are two dominant strategies, although as long as there are at least one dominant strategy, a Nash equilibrium is quite easy to find. But as long as there's two, just play the two dominant strategies, and that will be the Nash equilibrium. Okay, now let's go through a game where the strategies are a little bit more complicated. In this game, we have nearly all of the same assumptions as before. In fact, all of the same assumptions as before. The game is simultaneous. Information is perfect. Payoffs are profits. And again, the first payoff goes to the left player, and the second payoff to the top player. Here we have Apple computers and Dell computers, and they're choosing between a high price and a low price. In this scenario, again, the joint decision, that is Apple's decision as well as Dell's decision, is what creates their profit outcomes. And again, this is what happens in markets where you have a relatively few number of firms. Now their profits are jointly decided. In the real world, Apple computers and Dell computers, despite the fact that they're competitors, their profits are clearly dependent upon the decisions that both companies make. For example, how they price their computers. Okay, so let's go through the strategies just like we did before. If you're Dell computers and you think that Apple computers is going to choose a high price, you pick a high price and get 10, or pick a low price and take 40. 40 is better than 10, so the response, the best response for Dell when Apple chooses high is to choose low. If Apple chooses low, once again we see that Dell's strategy is to pick low. Dell's best response is to pick low. This means that Dell has a dominant strategy to pick low. Regardless of what Apple Computers wants to do, Dell will select low. Let's go through and develop the strategies for Apple Computers. In fact, we wouldn't even have to do both, since we know that Dell Computers is going to choose low. But let's go through them anyway. So if you're Apple Computer and you think that Dell Computer is going to choose a high price, you pick a high price and get 90, or you pick a low price and get 95. In that scenario, you'd rather have a low price. So when Dell chooses high, Apple wants to choose low. But when Dell chooses low, we see that a high price yields 95 and a low price yields 90. This means that Apple Computers would prefer to pick a high price if they think Dell Computers is going to pick a low price. And since this is in fact what our assumption is, because Dell Computers has a dominant strategy to pick low, and because Apple Computers has perfect information, and in fact would know that Dell Computers has a dominant strategy to pick low, this would mean that Apple Computers responds by playing high. In other words, the Nash equilibrium of this game is when Dell Computers chooses low and Apple Computers chooses high. Another way to check for the Nash equilibrium is to ask yourself, given the strategy of my opponent, do I wish to change my decision? In other words, if I'm Dell and I think Apple Computers is going to choose high price, do I want to pick something other than low price? And again, we've already covered this. The answer is no. Now, if you're Apple, given that Dell's going to pick low, would you rather pick low? And again, the answer is no. So in neither circumstance would either player choose a different option. So this is a Nash equilibrium. And we can in fact check any other option we could check any other outcome and actually see that in fact in each of them, at least one of the players would want to switch. For example, let's say that both players pick high. Well, if you're Dell and you think that Apple Computers is going to pick high, you would rather pick low. So you would prefer to move from here to here. In fact, if you're Apple Computers and you think Dell is going to pick a high price, you also don't want to be here, so you move to here. Let's check low, low. Well, if you're Apple Computer, then you would actually prefer to have a high price. Now, if Apple Computers were to pick a low price, Dell, as we already have covered, would also want to pick a low price. So Dell would like to be here, but as we've already just covered, Apple would not. And if we check this, we would see that clearly when Apple Computers picked low, Dell would much prefer to pick low than to pick high. So we can see that the only outcome of the game where neither player, if they take that opponent's decision into consideration, this is the only outcome of the game in which neither player wishes to deviate from the strategy. That's another clue that this is the Nash equilibrium. In this particular scenario where we have one dominant strategy, Dell Computers picking low, and one mixed strategy, Apple picking high when Dell picks low, and picking low when Dell picks high, is a situation where, because Dell has a dominant strategy, the Nash equilibrium is still very easy to find. Apple will be able to play their best response because they know, in a sense, what Dell is going to pick. So in a sense, we find the Nash equilibrium here because, again, we play the strategies and we know that Dell is going to pick a low price. So as long as you have one dominant strategy, even if you have a mixed strategy, the Nash equilibrium is very easy to find. Games get more complicated when both players have mixed strategies, and then you have to start thinking about probabilities, and then it gets very complicated. But that's for another subject for another time. Okay, so to wrap up, when we think about game theory, again, the way you want to think about it is break the game down into outcomes, break the game down into payoffs, whether they're payoffs or profits, or whether the payoffs are utility, which some models look at. what you're looking for is best responses. What is this opponent's best response to their opponent's decision? And go through, develop all the strategies for both sides of the game. And then usually, if you just play the game logically, as we've described here, you're able to find Nash equilibrium if they exist.